seated, please. A warm gratitude to all the dignitaries here. We have had wonderful progressive sessions for the last 2 days. I welcome you all for the session titled Satcom on the Move across land, sea and air. The ability to communicate from remote or mobile locations such as aircraft, ships, trains and vehicles without being limited by the availability of terrestrial networks results in increased productivity and efficiency as well as the business opportunities and markets that were previously inaccessible. The session will be chaired and moderated by Mr. Gaurav Kharod, Regional Vice President, Asia Pacific Intelsat. Can we have you on the stage, Mr. Gaurav? Very warm welcome, sir. Our keynote speaker, Mr. Paul Febvre, CTO, Satellite Applications Catapult. Mr. Paul? Do we have? Okay. We have a video sent by Mr. Paul. We would like that to play for you. The speakers will be Mr. N Jairam, Senior Director, Sales and Marketing, Hughes Communication India. Mr. Sir, please. Mr. Paul Febvre, CTO, Satellite Applications Catapult UK. Can we? Okay. And Alexander Jeuck, ICT and SpaceTech Professionals. Very warm welcome, Mr. Alexander. Mr. Kapil Kumar Sharma, Scientist Engineer, SG ISRO. And last not least, Bashir Patel, Inmarsat. Do we have Mr. Bashir? Okay. Mr. Bashir will be live with us. Thank you. Looking forward to an interactive session. Please, I leave the session to the chair. हाँ, would you have? Can we start the video? हाँ जी, yes.
वो DVI पे कर दो वापस. DVI पे कर दो. दबा दो ना बटन. DVI.
Good morning, dear friends and colleagues in New Delhi. I'm sorry I can't be with you in person this year, although I will be joining remotely the panel on satellites and drones later this afternoon. I'm Paul Febvre. I'm CTO at the Satellite Applications Catapult, a research organisation in the UK. And it gives me great pleasure to be able to present a few thoughts on the evolving landscape for satellite systems to deliver services to the maritime aviation and land communities. I've been working in satellite communications for nearly 4 decades. Firstly in BT Research Labs, and then after that as System Design Authority for L-band data systems at Inmarsat, where I worked for nearly 19 years. For the last 10 years, I've been working at the Catapult, covering multiple technology innovations, including advanced AI for Earth observation, the integration of satellite and terrestrial systems, and supporting the emerging economy of space. During my talk this morning, I hope to provide some insights into the driving forces which are stimulating demand for satellite services in each of the domains that are the topic of this panel session, maritime aviation and land systems. I will take a look at the legacy satellite communication systems, how they are evolving towards providing higher capacity, and how the emerging LEO constellations, which are leveraging advances in automated manufacturing and launch, are changing the landscape. I hope to spend a few minutes considering the drivers for future satellite systems with specific consideration of the technologies that may facilitate a future integration between satellite and terrestrial systems for 6G. Considering maritime services, our global trade today is fundamentally underpinned by and dependent upon ocean-going vessels, with a significant fraction of the Earth's resources vested in the ocean, both for food, production and energy, and a shift taking place from the extraction of oil and gas to direct electricity generating using offshore wind. All these factors are really changing the way in which the maritime economy is dependent upon satellite systems, and there are 3 factors which are driving change. The first is the need for sustainability. Maritime transport systems are a significant contribution to greenhouse gas emissions, and maritime-based farming needs to carefully control the impact on the coastal environment. The second factor is the need for improved operational efficiencies. The exploitation of digital connectivity, support electronic bridge, improved navigation services, remote vessel monitoring, and improved integration between transport modes, other smart ports, for instance. And the third is the continuous need to improve safety. Activities related to safety of life for artisanal fishing fleets, maintenance of offshore and wind generation infrastructure, and driving towards full autonomous transport vessels, which is principally for efficiency. Air transport systems have been dependent upon satellite services for decades for safety communications, position and navigation, and information services, weather, and increasingly airspace situation awareness. The transition towards electric aviation and hydrogen fuel cells, supported by autonomous systems, is creating higher dependency on such satellite systems. Passenger connectivity is an expectation on most European and oceanic flights right now, with air-to-ground and satellite services really being the first examples of truly integrated satellite and terrestrial systems. Probably the biggest change in airspace management, however, is likely to be the facilitation of beyond visual line of sight drone operations, initially for information assets, but increasingly for last mile freight and potentially the eagerly anticipated advanced air mobility or air taxis. The existing satellite systems will definitely need to be enhanced to provide the scale and capabilities needed for such platforms, and this is an area driving research. Perhaps we'll cover that a little bit more this afternoon. Certainly the Satellite Applications Catapult is doing significant work on advanced air mobility with our collaborating partners. Domains for satellite communications. Primarily this has been in the existing markets such as direct-to-home broadcast and broadband, satellite news gathering, finance and enterprise networks, construction, extractive and creative industries, as well as security and defence. However, it is increasingly the case that satellites are being adopted for consumer and leisure applications. The most exciting and demanding applications are likely to be for vehicle communications stimulated by the transition to autonomy. It is abundantly clear that the existing terrestrial networks will be unable to be commercially viable if attempting to satisfy the demand for connectivity when the driver is a machine, with the humans all being passengers and wanting to be connected, to be entertained, or to undertake work to increase productivity. The potential for a significant proportion of electric road transport platforms transitioning potentially to mobility as a service is likely to accentuate the demand still further. Let's take a look at some of the trends supporting the traditional maritime, airborne and land sectors. The majority of operators, either direct-to-home broadcast or broadband, enterprise VSATs or mobile satellite service providers, have largely been based in geostationary orbits. I'll talk a little bit more about LEO evolution later. Safety services and IoT, that's Internet of Things platforms, have tended to operate in the microwave bands up to and including about 6 gigahertz, whereas defence operates in UHF and X-band, but the high data rate systems operate in millimetre wave bands such as KU, KA and K. And there's transition potentially in the future to higher frequency bands, especially for the feeder links. Innovations in recent years have included medium Earth orbit satellite operators, especially SES with their mPOWER constellation for connecting remote communities, enterprises and theatres of operation. And even Viasat and Inmarsat's delivery of capability using highly elliptical orbit satellites to provide polar coverage shows the demand stimulus that's creating the opportunity for investment. I think the game changer has been the advent of large LEO constellations, with OneWeb and Starlink now fully operational, and Amazon Kuiper and others in late stage development expecting to be competing within the next 2 to 3 years. These systems offer both high capacity and low latency services, but almost by definition require a full global service offering in order to be commercially viable. These new markets for mobile connectivity for autonomous platforms are highlighting also the dependency on resilient and trusted position, navigation and timing services. One interesting development is the future capabilities for multiple satellite communication systems operating in different orbits to provide augmentations to existing global navigation satellite systems to provide higher availability and performance improvement, as well as assurance of the positioning services themselves. As Catapult, we've been working with OneWeb and others on such networks and have been able to demonstrate many orders of magnitude improvement in resilience to jamming and interference, as illustrated in the diagram on the right. The potential for integrating such systems into future satellite infrastructure drives some of the requirements into the future terminals, both the architectures and the antennas. And we believe that software radio technologies and platforms for essentially configuring technology utilization on the fly will make such concepts commercially viable. This is an area definitely in which we'll be able to collaborate to create new capability. Let's take a quick look at the evolution of communication systems for delivery of services to handheld devices. This was perceived as very promising from a business perspective in the mid-1990s, with multiple systems being proposed and developed. The only two survivors after the explosion of terrestrial mobile communications being the low Earth orbit based Iridium and Globalstar constellations, although Iridium could really claim that they are the only ones delivering two-way voice and low-rate data services, at least initially. Inmarsat, and now Viasat and Thuraya, also offered multi-regional services, and all of these systems were competitively priced with respect to terrestrial roaming services, so still viable for many businesses. But these systems have failed to achieve mass market penetration as they're not smartphones and could not really evolve at the pace of terrestrial network. Latterly, in the late 2000s, satellite radio was being the first successful integrated satellite terrestrial systems, and new attempts were embarked upon to provide integrated satellite terrestrial networks for voice and data, with a compelling service capability operated in geostationary orbit at either L-band or S-band. These were really pitched as competition to mobile operator networks, and two examples are TerreStar and LightSquared in the US, neither of which really achieved their goals, and in fact the satellites have now been moved. So S-band complementary ground component licenses over Europe are now run by EchoStar Europe on the next TerreStar satellite, which in principle could deliver services to a terminal much as the one shown on the right hand side, and Inmarsat for the European aviation network. Coming right up to date, it's increasingly clear that terrestrial networks are not able to deliver ubiquitous connectivity, and both Samsung and Apple are integrating satellite connectivity for emergency use into their products using the Iridium and Globalstar satellite networks. Integration into mass market devices is likely to be the tipping point for generating significant demand, which will stimulate investment in next generation systems. And there are multiple new entrants such as AST SpaceMobile, who are building and in fact have launched some initial satellites to prove the capability for delivering high data rate services to mobile platforms that can provide coverage extension and increased resilience. This is really the start of a new era of truly integrated satellite and terrestrial systems. So finally, let's take a look at the driver for satellite networks integration into 5G and future 6G networks. There are plenty of opportunities for using satellites to deliver backhaul capability for remote radio access network nodes, and these are being realised already, even with the UK Emergency Services Network integrating such capability into the networks. The real drive, however, will come from 6G networks. And principally, the main focus here is to provide increased energy efficiency, increased coverage, and a hybrid set of services that can provide intelligence and value to customers. One of the most distinguishing aspirations of 6G is that it moves from simply being a network for connectivity for people and things to being the fabric of the sensing internet, or otherwise the pervasive intelligent network. The explosion of exploitation of generative pre-trained transformer networks as part of the next generation of artificial intelligence realized, for instance, in instances such as ChatGPT, is likely to cause significant disruption to existing businesses and stimulate new ones. And the demand for connectivity at multiple layers of this distributed intelligence will be an imperative capability in order to realize the benefits of such systems. Satellites are indeed expected to be part of this future, with significant work taking place in standardization and many opportunities for developing new research, technology and products. One interesting concept, for instance, is the exploitation of geosynchronous orbits hosting tens to hundreds of satellites to provide coherent communications to complement terrestrial and low Earth orbit satellite constellations, albeit with higher latency. Such concepts provide very resilient, high-performance services to handheld devices while achieving extraordinarily high spectrum efficiency, as the spectrum can be used multiple times in each synthetic cell, shown illustratively in these little red dots on this diagram, that are created dynamically by the system, which is essentially using massive MIMO technology in a ground-based beamformer architecture. Such concepts are really only becoming practical today with the innovation and development that's taking place for the terrestrial network. One advantage of such a constellation is that it can be regional, for instance, a constellation dedicated to India. I'd like to wrap up my thoughts today with regard to consideration of what the future would look like. We've talked about satellite communication services for maritime aviation and land, and the evolution of the landscape. And one of the things that's becoming clear is that over the next few years, the satellite services will be almost indistinguishable from current terrestrial systems and effectively providing the utility required to enable users to operate anywhere in the world. However, these systems will require complete change of paradigm with regard to the way that satellite assets themselves are managed and operated. And it's likely to involve automation significantly in space, both for managing the deployment, maintenance and end-of-lifing of the systems. This brings new possibilities for the way economy of space will work in the future. For instance, the ability to build very large satellites, which could be for instance, for very large geostationary or low Earth orbit satellite systems for communication, but also for other paradigms as well. Things like habitats in space for tourism, manufacturing for drugs or optical systems, power stations, or even data centers. I mean, this is fascinating when you imagine what could take place between 2030 and 2050. And on a pathway to net zero, where at the moment there is no conceivable planet B, the only way to perhaps satisfy humanity's insatiable desire to be connected is to move the machines off planet. And only the space community can do this, and perhaps it is our future. So in summary, there's never been a more exciting time to be involved in the space sector. All sectors are experiencing high demand, and this is likely to be magnified by the transition to autonomous systems in each of these domains. Satellite systems will need to evolve to become increasingly relevant and able to deliver the services that would be required, and this transition has already been started. The technology is being developed for next generation wireless systems such as metamaterials, distributed processing architectures, optical systems, reconfigurable networks, and artificial intelligence will all be part of future satellite systems. Thank you for your attention. I hope to be able to meet and work with many of you in future. There's very much to do and so many opportunities. Let's try and find ways to work together to make the world a better place, empowered by space. Thank you very much. Enjoy the rest of the conference. Goodbye.
म्यूट है क्या वहाँ से म्यूट खोलो एक दो
So thank you, Paul, for that enlightening address. He catapulted. His company's name is Catapult, and he did catapult us to the future of space. Thanks for that, Paul. I wish you would be here next year and be in person. So we look forward to that. We have a guest also logging in from, I think, UK, Bashir Patel. I'll check with the organizers when he logs in. But we'll start the discussion today. The panel's topic primarily is around Satcom on the move. for across land, sea, and air. And just to give you a perspective of where we are, of course, there is a global perspective and there's an Indian perspective. We'll try and talk about both. We've got a panel where Alexander and Bashir, once he logs in, can give us the global perspective. And we've got the gentleman from ISRO, Kapil, and Jairam from Hughes, who will give us the Indian perspective. But broadly, let me just preface by saying that since 2018, when the IFMC license came in through the Indian regulatory process, from that point onwards till date, in the last 4 years, there have been multiple service providers who have gotten the IFC and maritime license in India. The services have started off rolling. There was a land mobility license which was added to the VSAT services license for VSAT operators in India. And that those services have also gone, have taken off. And we're going to talk all of that in this panel. Hopefully we should have enough time to go through some interesting conversations. So first let me set the stage by some rules that I feel may help a more immersive discussion. So we'll not have all questions to all participants. We'll have specific questions to specific participants depending upon their expertise or their global or Indian roles. And then I will try and have questions which are more generic across air, sea, and land mobility. And then there are specific questions which are pertaining to land mobility or maritime, which we'll come to later. So I'll start with generic questions first. One other thought. I'll take a break in between around 20 odd minutes from now. And in the meantime, if any one of you have questions, then feel free to chime in and ask questions. So my first question is a generic question across land, sea, and air. What are some of the key applications in each of these verticals? So we know we are talking broadband here, broadband delivery on maritime, on aeroplanes. What are the applications? We are not, just the connectivity is a service, but what is the application behind it which is really driving the need for broadband for a passenger, for a crew, or on land? You want to go ahead? All of you, one after the other. Jairam, you start.
Good morning, everyone. So briefly, I'll keep it very brief, and this is from a service provider perspective, an Indian service provider who is active in all three areas of Satcom mobility. When it comes to, I'll start with maritime. When it comes to maritime in India, what we have seen so far is the customers, or at least the Indian flag vessels, restricted to critical operational data. If you were to look at the applications, definitely all the ship owners or ship builders are investing on systems and moving towards that dream of autonomous ship with less manual intervention. But what is preventing them to forge ahead and take, because it needs more bandwidth, more capacity, more resources. So the inherent issue is still there, which we hope that the new space policy will solve to a large extent, is the cost of bandwidth. So that is one. And when it comes to maritime, there is another section, a big section, which is totally, I would say, not at all developed, is a fishing boat. Now, there are more than 100,000 of them who want different types of boats, mechanized, motorized, less than 10 meter, more than 20 meter, some goes go to even to the Gulf for fishing. And they're looking for a lot of efforts, and government focuses on tracking them and most on the safety side, but they're looking at communication, because look at the crew members, they are out in the deep sea for 2-3 weeks continuously, and they would like, what they would like to have is to have communication with their near and dear ones and the friends, so through video, voice. So definitely we don't have a, I would say, solution which is technically and commercially feasible in India, although globally there are many systems. I mean, you have various L-bands global service providers who have solutions made only for this. But unfortunately, we don't have access to L-band and S-band and maybe low-cost Ka-band asset in India. So that is the maritime side. On the land side, as Gaurav mentioned, it has just started. But we have seen a host of a large demand coming in for communication on the pause. I mean, again, if I were to really dig deep, go deep, it has man-portable terminals, vehicle-mounted terminals, and applications in defense, intelligence gathering, surveillance, electronic news gathering, which had moved away from satellite, is now trying to get back in there, and definitely all those NDRF is more and more using this for reacting faster to the emergencies and disasters. So, and I'm sure there are going to be more and more applications for the communications on the move also. That is also coming up, but that is one aspect. As far as air is concerned, in India, none of the domestic airlines have adopted IFC, primarily due to the lack of business case, and there are 2-3 aspects. One is almost all the existing aircrafts don't have inbuilt IFC infrastructure, and to do a retrofit, it will take 2 to 3 weeks turnaround, including the certification, which is a huge cost, apart from the terminal costing close to $500,000. But the good news is that there are many low-cost capacities coming our way, again, thanks to the new space policy. The LEO systems, many LEO systems are coming, which promise to bring down the cost of the antennas. And some, actually, to kickstart this, I think some government mandate is required, like making it mandatory by the relevant government authorities, maybe DGCA, Civil Aviation, TRI, or not allowing any new aircraft without inbuilt IFC infrastructure. So and incentivizing this domestic operators to, or encouraging them to retrofit and start the service by existing. So these are some of those aspects. And coming to the application in aero, apart from passenger entertainment or connecting the passengers, of course, the cockpit data, crew information, everything is this application. Sure.
Yes. Okay. Thank you. It explains in principle all the applications. Yeah. Or majority. Maybe where I'm adding is we see also quite some demand in the oil and gas industry, in the mining industry, where more and more data is needed in various places. On an international level, of course, beside government defense, yeah, which is a key driver in itself, the maritime segment is growing very fast. At the same time, we have seen on the aero side that there's also quite some engagements, and will be, because, for example, there's a term BYO, bring your own. So we have not the screens anymore in some of the planes. So, but you need internet connectivity. You need broadband connectivity. That's the idea here. And crew welfare, only to mention that in some countries they don't find that sailors anymore. They are selecting their vessel based on the Netflix or whatever they will get there. Yes, and then coming back, maybe more an explanation. What is Satcom on the move? Yeah, because I think we have to see Satcom on the move is it's maybe the satellite that is moving. Whether we're having fixed terminals, but if the satellite moving, so it's in principle a satellite on the move terminal, which is made to support that. On the other side, Satcom on the move is Satcom on the pause, Satcom on the halt, that nomadic approach, which I think was heavily used for digital satellite news gathering, for example, for disaster response. Many missions would have been impossible in disaster areas without having this connectivity, and not only on the L band, also utilizing KU band or KA band. Reason why these higher frequencies make a lot of sense is because we want to have small terminals, but that is then maybe an aspect I go later. The form factor of terminals and so on, that is a very essential part to discuss further.
Few applications of these SOTMs are in the strategic use for the strategic users. These can be used in the surveillance, high video resolution surveillance, intelligence surveillance can be used by the defense peoples. And when the troops are moving, it can be used for the communication purpose. Also, it can be used in a disaster situations, disaster management, and in the societal applications like telemedicine on the move. It can be used for the same purpose. Thank you.
Thank you. Bashir, if you can hear us, can you give us your perspective on what are the key applications that are driving the demand in these segments?
Thank you very much, Guru, and good morning to the panelists and all the colleagues participating in this session. My sincere apology for not physically being there. Unfortunately, I've been tied up with some other activities in Europe and so on. So we have a lot of meetings going on, as you can imagine, in terms of the preparation for the World Radio Conference that's coming up later in the year. As regards to the application, you're addressing your question. You know, I go back to the very early days of when we started satellite communication on the move. And as many of you recall, the whole concept of using satellites for mobility came through the Arthur C. Clarke notion of having geostationary satellites in orbit, 3 of them which would cover the globe. And of course, way back in the late 70s, the organizations, United Nations organizations like the International Maritime Organization, came up with the concept of providing safety communication given the HF. There was great difficulty by vessels in high seas operating and trying to, when they're in distress, trying to connect through fairly stormy conditions and you know, being able to be rescued and so on. So the concept of satellite on the mobile came along. And I think Paul, certainly from Catapult, has provided a very good historical perspective going back to the early days. And I remember putting in a lot of seed capital in terms of developing the phased array patch antenna technologies, which are today fitted on not just aircraft, but also on land mobile sort of vehicle operations and so on. In terms of 2 aspects really has governed us. One is performance and the other is resilience. Resilience in the network, given the fact that historically the satellite was being used for mobility for vessels and aircrafts and so on. I was very much involved in the early days of developing the systems. We looked at resilience in terms of 100% backup, given the fact that they were being used for safety communication. And so redundancy in the network were very, very important. So we went from 99.99% almost in terms of availability of the service for global maritime distress and safety, GMDSS, and more recently GADSS, which is a global aeronautical distress and safety services. Now, the applications were the 2 types. One is the user for the commercial usage in terms of the consumer, and the other is the cockpit or the operations on vessels as well as on airlines. So cockpit communication was quite important for operational reasons and monitoring and tracking of aircrafts, as well as the performance, engine performances, which are done by Boeing and Airbus and so on. So they monitor the aircraft itself in real time from the moment it starts its engines to the whole duration of its flight to the moment it lands at a gate at an airport and so on. So that monitoring is very, very important, and there are tolerances. So if any of the performance aspects of the engines and other exceed that tolerance, immediately they are alerted to the fact that there's something going wrong in that aircraft. So passengers, you know, can be sitting safely in their seats on an aircraft, but knowing the fact that the airline is actually monitoring and knowing the movements of their aircrafts all over the world. And they have their operation centers. And this is tracking, this is real-time data tracking in terms of performance of the aircraft, as well as cockpit communication to air traffic control, to weather. Air traffic control is largely getting a weather update and everything else. Passenger-wise, what used to happen, as many of you know, is you have avionic boxes on the aircrafts. These avionic boxes were moved every time you wanted to upload in terms of entertainment, in-flight entertainment, and so on. We didn't have in-flight communication. I worked on the aeronautical satellite communication system in 84, 85. We designed the first generation of aeronautical satellite communication. And that became apparent, obviously, today. We now have almost 40,000 civilian aircrafts, commercial aircrafts, commercial jets, as well as long-haul aircrafts fitted with aeronautical satellite communication. So performance and resilience. Now, what's happened in this time is the capacity has evolved enormously, because we moved from narrowband systems, L-band system, for example, for safety communication, to KU and KA band. And the KA band has allowed us to have much greater level of bandwidth and capacity. So we now are able to, instead of shifting avionic boxes, you just simply download, when an aircraft has a gate, you simply download all the up-to-date information, live news bulletins, all kinds of information that is necessary for medium to long-haul flights and so on. And that's the, if you like, the capability. And then, of course, within the cabin itself, users, passengers are allowed to access all the kind of data that is available on the onboard computers and so on. So these are the kind of unique applications which allows us to now move away from manning things to being automated. And this is something increasing now. And of course, we're getting into, as Paul pointed out, there are uncrewed aviation vehicles, particularly in urban environments, which is going to transport people and so on. And that is also controlled through satellite networks and so on. On maritime, very similarly, big passenger vessels have multiple high-volume data systems which are going through satellites and so on. And I think the future is going to be even more exciting, because you actually have big data on satellite itself. You've got a data center on board the satellite. And that will give you a tremendous amount of capacity in terms of information that needs to be downloaded instantaneously to vessels on the move, if you like. An automated vessel, in fact, defense forces are also looking at vessels which are basically uncrewed, if you like, and automated and controlled and so on. There are a lot of interesting applications that are coming about, both in maritime and aeronautical, but of course equally on land as well. Because I think Paul mentioned in his presentation overview the direct-to-device communication systems. You know, I worked on the first generation of the handsets years ago, 25 years ago. Today, direct-to-device, you take the latest series of an iPhone 14 Pro, and you actually have a satellite built into that. So you are doing direct messaging services either through Global Star on an iPhone or a Samsung through Iridium and so on. And I think, again, you'll see Viasat and Inmarsat and other satellite operators will also who are looking at investing in direct-to-device kind of communication for mobility management and so on. So a lot of interesting stuff coming along, a lot of applications, interesting applications, which is driving the market in various areas, both in aeronautical, maritime, as well as on the land side of things for disaster communication. Thanks.
Thanks, Bashir. I'm going to take the next question specifically for Alexander and Bashir, but I would want to keep it short, preferably as short as my question, which is pointed, which is, what are the global concerns, if any, across these three segments? So we're not talking direct to device here. Let's focus the discussion on Satcom on the move, broadband, excluding L-band, S-band. We're talking higher bands, broadband. What are the global concerns, if any?
Okay, good that you try to be pragmatic here, because we having MSS services, mobile satellite services.
We're not talking that.
That's not what we are talking about. We are talking about Satcom on the move, means FSS services utilized. So here, if we having Satcom on the move, if we have terminals that need to be adjusted to the satellite, interference is the biggest issue. And interference need to be mitigated, or it need to be avoided, better to be avoided, yeah? And therefore the satellite industry means the people who are building the terminals together with the satellite operators, they have taken great effort over the last years to make standards and procedures to deal with that. Yeah, going a few years back where we had a lot of interference with occasional use. Yeah, because occasional use means switching on, switching off, switching on, switching off. That is a dynamic process, and therefore we intended then to utilize some so-called carrier identification. Yeah. On the DVB signal. On the now on the Satcom on the move terminal, be it for maritime or be it for trains, we have to fulfill certain standards by the satellite operators simply to make sure we are not destroying our own ecosystem we are all depending on and working on. So it's a joint approach, that's what I want to say. I was working for a satellite operator, I was working with many other satellite operators, and it's really a joint approach which we are seeing around the world, people working together to make sure interference is mitigated.
Excellent, Alexander, thank you. Bashir, over to you. What are the global concerns, if any, for Satcom on the move across maritime, aero, and land mobility? And we are, with your experience on spectrum management, etc., if you can bring that angle as well, if there are any.
Sure. Thanks very much, Gaurav. Yeah, I think primarily, I mentioned about performance and resilience. The other key driver today now is the use of Ku and Ka band for capacity. Capacity and bandwidth, which are absolutely necessary, and of course, there's a huge amount of investment by all satellite operators getting into with Ku and Ka band. That spectrum in Ku and Ka band, which is extensively used on a global basis we're looking at over 200 odd satellites that are operating, providing high bandwidth capacity for Satcoms on the move, for airlines and for maritime operations and so on. That huge level of investment provides coverage, of course, over the Region 3, which is the Indian subcontinent and Asia Pacific and so on. Now, basically the concern we have is obviously as Alex mentioned, is its avoidance of interference. That means that particular spectrum that is being utilized in 27.5 to 30 gigahertz, and also in the Ku band as well. That spectrum must be protected and not to be interfered to by terrestrial networks and terrestrial satellites. Now, you may wonder, well, how is that happen? I mean, I've flown over India at 30,000 odd feet, and I've had 3 bars on my phone, 3 bars on my mobile phone sitting next to a window. What does that mean? It means I'm getting signals from base stations on the ground up to as high as 30,000 feet. And when you get an aggregated level of signals going together from all these base stations from different elevation angles, then the satellite receivers, which are still sensitive, 36,000 kilometers above the equator, can still get that interference issue. And I know India, for example, and ISRO has interference on the 2.6 gigahertz on the satellites. Inmarsat also experienced the impact of 4G base stations and affecting our S-band services, for example, in 2 gigahertz and so on. So we do get interference, and this has been reported, by the way, to the ITU, the authority, the responsible authority for the United Nations, International Telecommunication Union. So interference does exist, does happen, and I think it's important that the regulations in place make sure that these bands, which are used not just for high capacity performance in serving satellite communication on the move, for airlines and ships and land operations, including disaster management, disaster logistics and so on, are protected. These bands are very critical for satellite services with the billions of dollars worth of investment that's gone into it.
Thanks, Bashir. Okay, so the next question goes to the Indian players on the dais here. Maybe Kapil, we can start with you. Where do you see, and this is, I'm straight away heading into the Indian scenario. It's been 4 years since the licenses have been given for IFC and maritime. we have no single domestic IFC player so far. Not many maritime players in the domestic market as well, maritime offtake. So the question to both of you is, and we can also address land mobility. What are the key pain points for the industry in India? Why is there little or no growth in those 3 markets which have opened up in the last 4 years?
Mainly the growth hindrance is that the cost involved in the technology. If you see they are using the antenna which is accurately pointing the phase array antenna, which is a complex technology. As the number of the elements are going higher, by controlling and steering the beam electronically is too complex. And maintaining the facility cost itself is high. Overall, if you see the technology cost is high, that's why it's not easy to penetrate in the commercial markets.
Jairam? So I would like to give a perspective to the cost. Cost is definitely an issue. India is a place, it's unique. In fact, where you get the cost of a GB is less than 10 rupees, 8 cents, which is, I think, nowhere else in the world you get the data so cheap. So there's a perception in terms of, it is not the affordability, it is a perception that why should I pay so much more for satellite? And satellite definitely can never compete with terrestrial anyway. But at the same time, it's a fact that the input cost or the cost per bit in India is high, one of the highest. In fact, just to cite an example, we service a lot of international customers or vessels coming from, specialty vessels coming from outside India. And when they come to India, see the cost of bandwidth, they cut down the requirement by more than 70% to accommodate the cost within their budget. So, this is just, it's a stark, it's a telling statistics, and it's very practical and what we experience. So what it needs is, and I think Aero, I'll touch upon Aero. Aero is a case of not having a viable business case because nobody pays for Wi-Fi in India. Including all of us. We would rather go for free Wi-Fi. So it needs some smarter, I would say, business modeling, incorporating the basic Wi-Fi, like Emirates. Some of the leading airlines are doing like basic messaging is inbuilt into the fare. And of course, it needs certain push from the government, mandate from the government, and it needs both a push and a pull. Pull is always there because post-COVID, I believe the hunger for data and being connected is more than ever. So I think it's a case of business case, lower capacity, lower cost terminals, find a solution to get the retrofit more, I would say, within, say, 7 days, 8 days, the entire process, a combination of things. Land, I would say, is just started. So we do see a lot of demand, but I think it will evolve. And on the positive side, there are a lot of, thanks to Government of India, Make in India push, a lot of Indian manufacturers also come up with Made in India products, which makes it easier to get into the Indian ecosystem, government ecosystem, and of course, brings down the cost.
Thanks. I'm going to pin both of you down, the Indians on the panel again, because they only talked about cost and they've talked about generally the availability of capacity, etc. No one of you mentioned either the technology or the regulation or the environment. So are you saying that there is no pain point associated to the regulatory climate, to the technology available in this market? Are you happy with both Jairam and Kapil? You go first.
It's a mixed bag. I would say, as I mentioned, the new space policy, which we are again waiting for more clarity, does promise sort of open skies, and then we can look at bringing in low-cost capacity, the latest technologies, and of course the NGSOs are coming into India. So that does take care of the cost. We hope that would take care of cost to some extent. But on the regulatory side, there is definitely a pain point as far as the Indian VSAT service provider is concerned. Especially in maritime and aero, we are restricted to being a regional provider or a local provider. That does, because these are global services, in fact. in India, for example, there are 1,000 odd vessels, and maybe half of them go outside India. But they would like to an end-to-end solution. So, of course, we can have roaming arrangement and all, but then to be more effective, cost-effective, and more competitive, we need to have a mandate to, or ability from a regulatory perspective to have a global service from India. I mean, I think there are too many restrictions in there from there. Land, we are going through the hoop in terms of getting different approvals. We'll come to know because each type of terminal needs a TC approval. But I think these are teething problems, and once that is sorted out, it will be a smooth sailing. And this is our personal experience also of getting certain approvals faster. Aero is a different thing. Aero, I think it needs, as I mentioned earlier twice, a regulatory push or a mandate is required to get things going with the domestic aero.
Juggling the microphone between two of you, I'm hopefully allowed to add something on the technology side, not on the regulatory. I think personally that the satellite operators, they are ready, yeah. But what we really need to see more cooperation is on the development of terminals, because what is happening at the moment is phased array antennas. That's not a new technology. It was invented during or after the Second World War. But to make it cheap, yeah, to make it a mass product is needing a lot of money. And the only two who maybe make it the right way, this is Elon Musk, putting around $3 billion on the table and saying, okay, I want to have that Starlink terminal. And Amazon Kuiper investing $10 billion, and out of that, a high amount will go also in the terminal, which they had to delay for a few years because it is complex to make it small. The form factor is so important on Satcom on the move. The power consumption of a terminal needs to be very low. The environmental data needs to be fulfilled. It's not a handset again, it's a satellite terminal. And that requires a lot of engineering. And there I believe it is good if the different countries, the whole industry is working together to make that happen, to get that terminal even cheaper.
In ISRO, we have started the development of the SOTM terminal recently for reducing the cost. We have started the low-cost SOTM terminal development recently. In phase 1, we have started the development of the receive-only terminal, which can be used for the entertainment purpose in a bus or on a train like this. It is a electromechanical tracking antenna-based system which can be used for the low-speed vehicles in a normal scenario, road scenario. But in phase 2, we have started the development of the two-way SOTM terminals as well, and which is again using these electromechanical-based antenna tracking and pointing systems. But in the same way, we have started this development of the phase antenna array systems to improve the SOTM capability for the faster moving vehicles which have the higher dynamics in the vehicle for the shock or the different vibrations capacity. At the same time, we have now started the development of the facility for the SOTM terminal development. We have started a motion emulator terminal that can now emulate the motions of vehicles. We have started, it will be the motion emulator in a building which have a transparent RF signals, and we are going to develop in very soon. We have taken, we have put some sensors, INS sensors and GNS sensors and which are mounted in the vehicles, and we have taken the values samples at 200 Hz and then we have decided the specification of the motion emulator sensors, and now we are hopefully that it will again we are able to develop a low cost SOTM terminals that can bring the penetration in the market of the SOTM terminal.
So, sorry, Alexander. The audience question, if anyone has a question, I've got 2 hands raised already, 3. So we'll stick to the first two, Prabhat, if you don't mind. The first two, they come up at the end. Shrikant, you can shout.
Thank you, everyone. I am Shrikant. I handle commercial aviation solutions for Intelsat. My question might be focused a bit towards Bashir, but I would encourage anyone throwing focus on this, right? So, industry, Satcom as an industry, is quite focused on innovation to improve the spectrum of applications, efficiencies, economics, and reach new horizons, right? That's what is happening across. Contrary, the demand for frequency spectrum is increasing across various technologies, especially the push from IMT has increased from C-band, KU-band, now Q and V bands as well. So looking at this, is there a consideration from regulators, domestic as well, the global, or the push from the industry to maximize the utilization of available Satcom spectrum across the applications instead of being restrictive like, okay, this is FSS, this is BSS, I will run only these applications in this, these applications in the other one. So can we converge and start looking at maximizing the potential of available spectrum for Satcom as an industry? Is there any thought around that?
So Bashir, did you get the question? It's up to you.
Gaurav, I did. And I think it's a very good question in the sense that when you look at the availability of the amount of bandwidth, megahertz of spectrum that is available for whether we call it FSS, fixed satellite services, or MSS services, let's concentrate on KU and KA band. These are the high capacity, high bandwidth sort of services that we're looking at, both with the ISRO satellites as well as international satellite, foreign satellite operators. That capacity we have, the bandwidth that we have available is not extensive. It's actually fully loaded. When you look at the 2 gigahertz of spectrum in KU band, and similarly, you're looking at about 2.5 gigahertz in the millimetric wave in the Ka band that is being utilized. That is, when I mentioned the number of satellites, we're looking at over 200 to 300 odd satellites globally across the globe. Just over India, you have about 100 odd satellites in Ka band and also KU band and so on. So these satellites are fully loaded in terms of providing services across the spectrum, across this band. There is no spare capacity. If anything, we are now looking for additional spectrum capacity in Q and V bands for feeder links and so on. And then on top of what we have today from GEOs and MEOs and LEO operators, Paul mentioned Empower, for example. When you look at Starlink, you look at OneWeb, all of these new generation of operators that are coming on board are also using KU and KA band. Okay, so in terms of having any spare capacity, there isn't any. And when you get then the terrestrial operators wanting to come into this band, to coexistence is not feasible. That is actually technically proven. Okay, so there is no coexistence between an IMT and satellite services, particularly in the bands that we're talking about. So what do? You've got to prevent any interference to the services that are ongoing. And there are a vast portfolio of services that are happening in KU and KA band today for satellite communication, on the move, as well as ubiquitous fixed services, fixed satellite services. When you have 300,000 VSAT terminals in India using KU band, and some of them using KA band, those terminals can't be interfered to. They're carrying traffic, they're carrying commercial traffic, and so on. So it is very critical that the government recognizes the fact that you have some very essential usage of these spectrum going on for all the different types of services and different categories of users that we have, from government agencies to defense forces to commercial usage, multinational companies and so on. There's a vast array of users. And these multi-stakeholders are very, very important because the services that are provided are very essential to them. So the spectrum is a very, very important aspect that has to be preserved and safeguarded for the kind of applications and services that are provided. And the government has to acknowledge these things and recognize that this is how it is used. And therefore, they've got to safeguard that and protect it. There are a lot of other bands that are available for IMT mobile services, for terrestrial mobile services. And I think the future is going to be such, very exciting when we look at 2030 and beyond vision 2048, 100 years of India's independence. We need to look at a much more integrated solutions where we use the different kind of technologies, terrestrial and NTN, which Paul mentioned, next non-terrestrial networks, basically, together with terrestrial networks, and the ability, because we now have much greater level of computing power and capacity, so the user air interface can be quite dynamic in the design and so on. So the future is such that we will complement each other. We will have a hybrid kind of more holistic approach to doing a network architecture using both terrestrial and non-terrestrial networks. And therefore, spectrum will be utilized much more effectively. I mean, today your mobile phone, the handset you have, an iPhone, is a multi-band phone. It cuts across 800 megahertz right up to 2.2, 2.4 gigahertz, and so on. You have multi-band systems. And again, the next generation of devices will have multi-band. I mean, for example, the Global Star system on iPhone today is using 1.6 gigahertz and so on. So you have different bands, multi-bands, devices that will come about. There's a lot of investment that's going in. And as Alex pointed out, we did a lot of seed capital when we came up with different kind of devices for airlines and ships and everything else. And that investment is going in from India, from ISRO. Increasingly, the way to do is to find cheaper ways, more economical ways of mass production and so on. So automation is going to come into this as well. But I'm pretty confident we're going to get the cost down. There's a difference between cost and price, by the way, and there's a bit of confusion here. That needs to be cleared up. Cost is what it costs to manufacture or produce. Price is what an end user pays for the service, okay? So there is basically from a cost to a price, there are different, if you like, there's margins that are added on by different value-added providers, given whatever value they add to that service. And so on, in terms of integration and applications and so on. So the cost per megabit is a fraction of a cent today, from a geo from a geo constellation or a LEO constellation. That is the reality today. That wasn't the case 30, 40 years ago when I started my career in this business. But today it is. It's a fraction of a cent per megabit. So that's the cost of producing per megabit. Now, the price is a very different thing. I've seen prices of a gigabyte per dollar, 1 gigabyte through a satellite per dollar. So that is the price an end user is paying. So we are drastically coming down in price and cost, and so on. So I think this is the way. I'll stop at that. Thanks.
Thank you. I only wanted to add the question here was in principle of the usage of the spectrum, and of course we here we are asking as a satellite industry the government for support, but at the same time I want also to express the hard work which was done over the years from our engineers, because we have increased dramatically bits per hertz. Yeah. So in principle, we have changed modulation schemes, higher order modulation schemes. We working very efficiently, I would say, yeah. And there are also limits, and that's why it is needed to allocate spectrum, especially also for the satellite operators. But we are working very hard on that. On Satcom on the Move, you need to balance between size of terminal, capacity available, and so on. Yeah. Maybe last word.
So I'm sorry we don't have any more time for any more questions, but thank you so much for patiently listening to the conversation here, and I'll get the organizers back on stage. But thanks, everyone.
Thank you. Thank you, ladies and gentlemen.
Thank you.
Yeah, that's been a very nice audience here. I guess we all will believe it has been a very informative and cognitive session towards the progress of space communications. Now we'll head for our tea break. You can have a 15-minute tea break, please. The next session will resume at 12 noon. The parallel 4 sessions as continues. Thank you, distinguished panelists. Thank you, Chair, for a very wonderful session here.
Thank you.
Is it 1 cent?